So problem number 1 says a 4 kilogram block slides on the track with negligible friction except for a region of length 0.25 meters. The block compresses at 8,000 newtons per meter spring by 6 centimeters, then is released from rest. The block slides up the ramp, then returns, and the maximum compression of the string is 500 centimeters. Part A asks you to find the coefficient of kinetic friction between the block and the region where there is friction. The first thing we have to acknowledge is that energy is conserved, so therefore kinetic energy equals the change in potential energy. And work done by friction will take energy away from the system since it decreases the energy each time. So the initial spring potential energy is calculated by 1/2 kx squared. Plugging in the values given, we get an initial energy of 14.4 joules in the system. After the block goes up, passing the kinetic friction once, and then it goes down the ramp, passing the area of friction twice, that means energy will be taken away. And it says that the spring is then compressed by 5 centimeters, so plugging it into the same spring potential equation, you get the energy to be 10 joules. So that means for one direction, 2.2 joules of energy are lost, since the difference in this potential energy divided by 2, which is constant each time, is 2.2 joules. Therefore, that means the kinetic system takes away, or the frictional system takes away 2.2 joules every time the block passes over. So therefore, the work done by this force is equal to mu n times the distance. So therefore, mu n is also equal to mu mg. And plugging in the mass, the acceleration due to gravity, and the distance of the frictional patch, you get mu k equals 0.224.
So part B of question 1 asks, describe the motion of the block until it comes to a stop. In describing the motion, you should 1. Describe how many times the block passes back and forth, and 2. Determine where the block stops. So as we figured out in the problem before, there's 2.2 joules that are lost in each direction that the block goes up. So we initially started with 14.4 joules. So therefore, on the 7th run, after you keep subtracting 2.2, there's 1.2 joules left. So then therefore, that makes the block pass back and forth 3 times because there's no more energy to take away because there's only 1.2 joules left. So from part A, we can conclude that the back and forth 3 times. So then when we needed to determine where the block stops, we know that the initial energy is equal to the force of friction times distance. And what we need to remember is that for the force of friction is work done by friction, and that takes energy away from the block, so it has to stop at the patch of friction that we were given in the problem. So we started it off with 1.2 joules, which we solved from the first part of the question, and you set it equal to U sub n times distance, which is the normal force. And then when you plug that in, you know that U sub n is the same as the coefficient of kinetic times mass times gravity. So you're going to plug in the same values, and you got 0.224 from part 1 as well. And when you solve for distance, you get 13.7 centimeters.